Hi everyone, back with a few more implicit differentiation examples, some a little bit trickier or that maybe require a little bit more thinking. All right, so our first question, use implicit differentiation to find dy by dx, and again we're remembering that dy by dx is the same thing as y prime or the slope of the tangent. Okay, so it's the derivative, or the derivative of y with respect to x. Okay, so use implicit differentiation to find dy by dx. So I'm assuming you've watched the previous video and you know what we're doing. We're just looking at a few different examples. So derivative of x cubed is 3x squared. Derivative of y cubed with respect to x is going to be 3y squared times the derivative of y with respect to x, which is our slope of our tangent, or y prime. And then 6xy, we would realize we would have to use the product rule for it. So the first function is a function of x, 6x, multiplied by a function of y, in this case just y. So derivative of 6x is 6, and derivative of y is dy by dx. And so using the product rule, derivative of the first times the second plus the first times the derivative of the second. And then we want to get dy by dx by itself, because that's the derivative. So I'm going to subtract 3x squared on both sides, and also subtract 6x dy by dx on both sides. So I have the terms that have dy by dx on one side, and the terms that don't involve dy by dx on the other. And then I can common factor out dy by dx. And then divide both sides by 3y squared minus 6x. And then I get that dy by dx, for the slope of the tangent, y prime, is equal to 6y minus 3x squared over 3y squared minus 6x. Okay, some people might say, well, Mrs. Northwood, I can go straight from this step to this step. I can common factor and divide in my head. That's okay if you've been doing the homework and you're getting it. That's okay. All right, so here's one that maybe looks a little different than one we've tried before. So this is kind of back to basics. We first want to write it in exponential form before we take the derivative. So all I did there was rewrite the function. I haven't taken the derivative yet. Okay? So now I'm going to take the derivative. So the derivative of x to the 1/2 is 1/2 x to the negative half. Here, because it's a function of y, it's going to involve the chain rule, so it's going to be 1/2 y to the negative 1/2 times dy by dx. And the derivative of 1 with respect to x is 0. I might want to write it without the negative exponents now, so that would be 1 over 2 root x plus 1 over 2 root y dy by dx. And again, it's dy by dx that I want to get by itself. So I'm going to subtract 1 over 2 root x on both sides. So now I've got 1 over 2 root y times dy by dx is equal to negative 1 over 2 root x. And then I'm going to divide both sides by 1 over 2 root y. It actually works out to a really pretty derivative here if we think about it. So when we divide fractions, we multiply by the reciprocal. So there's the first fraction is negative 1 over 2 root x. I'm going to flip the second one and multiply, so 2 root y over 1. Multiply the tops together and the bottoms together, so I'm going to get in the top negative 2 root y and in the bottom 2 root x. The 2's, I would divide them out just because it's so easy to. So I end up getting negative square root of y over square root of x, which is a pretty derivative to get. Okay, so there's an example of one that's maybe a little tougher than the ones we worked on last time. C is a little bit challenging because it involves two product rules, so just use lots of paper for your side work here, but it's not that much more complicated. So you have to recognize that this one's going to involve a product rule, and so is this one. So starting my first product rule, my first is 2x and my second is y squared. And my derivative of 2x is 2, the derivative of y squared is 2y dy by dx. So when I derive 2xy squared, derivative of the first times the second is 2y squared, plus the first times the derivative of the second, so that's going to be 2x times 2y, which is 4xy, also times dy by dx, minus, so the derivative of y cubed is going to be 3y squared times dy by dx. And then I have another product rule. So the first function is 3x squared, and the second one is y. The derivative of 3x squared is 6x, and the derivative of y is dy by dx. So derivative of the first times the second is 6xy, plus the first times the derivative of the second, 3x squared dy by dx. So I want the terms with dy by dx to one side, so I'm going to subtract 3x squared dy by dx on both sides. And I'm also going to subtract 2y squared on both sides. So I've got on the left side now 4xy dy by dx minus 3y squared dy by dx minus 3x squared dy by dx. And on the right side, I've got 6xy minus 2y squared. Common factor dy by dx on the left side. 4xy minus 3y squared minus 3x squared. Divide both sides by 4xy minus 3y squared minus 3x squared. So therefore dy by dx is 6xy minus 2y squared over 4xy minus 3y squared minus 3x squared. So that one was challenging because it involved the product rule 2 times. Next one, find the slope of the tangent to the curve 1 over x plus 1 over y equals 1 at the point 3/2, 3. Okay, so we're starting with the equation 1 over x plus 1 over y equals 1. To get it into a more derivative-friendly form, we're going to write 1 over x as x to the power of negative 1, and 1 over y is y to the power of negative 1. And now we'll take our derivative. So the derivative of x to the negative 1 is negative x to the negative 2. The derivative of y to the negative 1 is going to be negative y to the negative 2 times dy by dx, and the derivative of 1 is 0. So this is actually negative 1 over x squared minus 1 over y squared dy by dx equals 0. add 1 over x squared to both sides. And we're going to get negative 1 over y squared dy by dx equals 1 over x squared. We want to get dy by dx by itself. So if I multiply both sides by negative y squared, that's going to leave me with, so think about this here, I would have positive y squared over y squared, which is 1. So I'd be left with dy by dx on the left, and on the right I'd get negative y squared over x squared. And we're asked for the slope of the tangent at the point 3 over 2, 3. So we want dy by dx at the point 3 over 2, 3. So that's going to be negative 3 squared, like that. So only the 3's in the brackets, the negatives out front, over 3 over 2 squared, which is going to be negative 9 over, so when we have a fraction to a power, that's going to be 9 over 4. And then we know when we divide by fractions, we multiply by the reciprocal. So that's going to be negative 36 over 9, which is negative 4. So therefore, m tangent is going to be negative 4. And our last question, find the equation of the tangent line to the curve y to the 5th plus x squared y cubed equals 10 at the point negative 3, 1. Okay, so start off with y to the 5th plus x squared y cubed equals 10. And now we can start deriving it. So the derivative of y to the 5th is 5y squared times dy by dx according to the chain rule, plus x squared y cubed is going to involve a product rule. So the first function is x squared, the second is y cubed. Derivative of x squared is 2x, derivative of y cubed is 3y squared dy by dx according to the chain rule. So that's going to be plus 2xy cubed plus x squared times 3y squared, so I'm going to write that as 3x squared y squared dy by dx equals, and the derivative of 10 is 0. So I'm going to subtract 2xy cubed on both sides, and then also common factor out dy by dx on the left side. Divide both sides by 5y squared plus 3x squared y squared. I just saw something here. This should be 5y to the 4th. Hopefully you guys saw it earlier than me. Derivative of y to the 5th is 5y to the 4th. Times dy by dx. Plus 3x squared y squared. Okay, so then we end up getting dy by dx is negative 2xy cubed divided by 5y to the 4th plus 3x squared y squared. But we want the equation of the tangent line to that curve at the point negative 3, 1, so we want dy by dx, or the slope of the tangent at the point negative 3, 1. So that's going to be negative 2. X is negative 3 times 1 cubed over 5 times 1 to the 4th plus 3 times negative 3 squared times 1 squared. So that's going to be 6 over, that's going to be 27 and 5, 32. and we can divide by 2. So that's 9 times 3 is 27, and 5, yep. So that's going to give us 3 over 16. So we have that the slope of the tangent is 3/16. And we also have the point, -3, 1 for x and y. And we can use y equals mx plus b. So y is 1, m is 3/16, x is -3 plus b. Maybe you want to multiply everything by 16. Make sure you multiply everything though. Add 9. So b ends up being 25 over 16. So therefore the equation of the tangent line is y equals 3/16 x plus 25 over 16. All right, thanks guys.